In this example, we are going to convert each of the following questions from the given angle measure, either in degrees or radians, to the other angle measure. So if we're given degrees, we're going to convert it to radians. But if we are given radians, we're going to convert it to degrees. We've been asked to state exact answers rather than approximations. That means we are not going to be evaluating stuff like pi. Okay, so if we are going from radians to degrees, okay, then there will be no rounding. But if we're going from degrees to radians, we must be including that symbol of pi. Okay, so let's take a look. So this first one here is 30 degrees, which means we are converting to radians. So if we are converting this to radians, that means we are going to multiply this by pi over 180. Okay? And since we know this is just 30 over 1, okay, as any number is, we now have two fractions that we are multiplying. And when we multiply fractions, we multiply the tops and we multiply the bottoms. So that brings me to 30 times pi, and since we're dealing with exact answers, it's going to be 30 pi divided by 1 times 180, 180 there. Now I can reduce this, so this is the really important part here. We must reduce the fraction. Okay, so this is going to be a pretty clean reduction here, which is nice. So if I reduce this, 30 divided by 30 is 1, but 180 divided by 30 is actually 6. So, as a reduced fraction, 1 times pi, that's just pi, and on the bottom I have 6. So 30 degrees is actually equal to pi over 6. So this is my exact answer, right? No approximations, I still have pi in there. We are all good. On to the next one. I have pi over 12, and since there's a pi symbol, that means this is radians, which would imply that I have to convert this to degrees. So, to convert it to degrees, I'm going to multiply it by 180 over pi. So again, two fractions, and I am multiplying. So when I do that, I multiply the tops, and I multiply the bottoms. So what does that look like next? Pi times 180 is just 180 pi, and 12 times pi is 12 pi. Now we reduce, reduce, reduce. Nice thing here, I've got a pi on the top and a pi on the bottom, so those cancel, which is exciting. And then 180 divided by 12, that's actually a clean number. So if I do 180 divided by 12, it gives me 15 degrees. Okay. Now, you notice that I put the degree symbol here, but I didn't put the radians symbol here. When you have a pi over 6 and we're talking about angles, it is just assumed that since you have a pi in here, that this is radians. So if you feel more comfortable to include that, you can, but if it is not there, it is just assumed that this is in radians. Okay, so you're not going to see me writing this radians unit here. Okay, but because this is degrees, we do have to include the degrees here. Now, one trick I found helpful to remember, whether it's pi over 180 or 180 over pi when converting, is really just to focus on the pi symbol. Because if we are in radians and we want to convert to degrees, you notice that there is no pi symbol here. Okay, so that means somehow that pi has to cancel. Looks like just like it did here. So that's my little hint to use this version where the pi is on the bottom, because if it's on the bottom, the two pi's will cancel. Okay, where if we're converting from degrees to radians, my initial degree here doesn't have any pi in it, so I need to introduce pi. And the only way I can do that is having pi on the top, so that when I multiply my fractions, I do have pi on the top here. Okay. That's a little trick to help you remember which one converts. Okay. So Let's do the next example. 7 pi over 4. So since I have a pi, that means I am in radians. And if I want to convert to degrees, I have to cancel out that pi, which means I'd be multiplying by 180 over pi, so that those will cancel. Okay. Now, what I did up here was I multiplied first, and then I reduced. But if you are comfortable enough to go straight into reducing diagonally, you can absolutely do that. Because I notice here right away that I could cancel those pi's because they're on a diagonal. Okay. Now, if you feel comfortable reducing this 4 and 180, you can. But I'm actually just going to multiply this out, and then we'll do the dividing. So let's take a look what this looks like. 7 times 180 is 1,260. And 4 times the 1 that's left on the bottom is 4. And 1,260 divided by 4 leaves me with 315 degrees. Okay, so on to my next example. I have degrees, and that means I'm converting to radians, which means I need to introduce the pi symbol somehow. That means I'm going to multiply by pi over 180. 135 over 1. And now I multiply my fractions. 135 times pi is just 135 pi. 1 times 180 is just 180. Okay. So I have a pi, nothing to cancel. That's good because that pi is going to stay. But when I reduce my fraction, and you can double check my numbers here, this should reduce down to 3 pi over 4. So I want you to go through that reducing process on your own, okay, and just double check that you get 3 pi over 4. Got 2 more to do here. I have 210 degrees, which means I'm converting to radians. If I'm converting to radians, I have to introduce the pi. So the pi is going to be on top. And I am multiplying two fractions. So what is this next line going to look like? 210 pi over 180. And again, when we reduce, you double check my math here. This should reduce down to 7 pi over 6. Okay. My last one here, I have 5 pi over 3, which means I am converting to degrees. And if I'm converting to degrees, I have to cancel out that pi symbol. That means I multiply by 180 over pi. So I'm actually going to do my reducing right here instead of going through. So I know my pi's will cancel. Again, we always have to be canceling diagonally. Okay, but this 3 and 180 can be reduced, can't it? Well, if I can take 3 out of 180, that's clean, right? If I take a 3 out of 3, that leaves me with 1. But if I divide 180 by 3, that leaves me with 60. So before I go multiplying all my fractions, let's see what this looks like now after I've done all my canceling. Well, I had 5 pi, but the pi canceled, so that just leaves me with 5 over a 3 reduced down into a 1. And over here, the 180 was reduced down to 60 over, and I had canceled that pi, so 60 over 1. Well, that's not so bad. 5 over 1 and 60 over 1, that's just 5 and 60. So, in the end, 5 times 60, which gives me 300 degrees. So that is how we convert back and forth from degrees to radians.